Hello everyone, welcome to our YouTube channel Physics Hub. Hello students, are you preparing for class 10th board physics and feeling confused with formulas? Don't worry, in this video you will get all important physics formulas of light and electricity in one video. This video is perfect for quick revision and last minute preparation. While watching this video, make your own physics formula notebook, write every formula, pause the video if needed, and revise it regularly. This will help you score better marks in exams. This single notebook can become your final revision weapon for exams. So take your notebook and pen. Let's make light and electricity easy and scoring. Let us start with electricity chapter formulas. First one, current. What is current? Current is the flow of electric charge or the rate of charge passing per unit time is the current. So here I is equal to Q by T. So here I is the current and Q is the charge and T is the time. And the SI unit of current is ampere and it is denoted by A. Next, charge. Charge or electric charge. It is the fundamental intrinsic property of a matter, and here we know that some properties of charges like charge is additive in nature, charge is of two types, one is positive and another is negative. And next is charge is quantized, that is Q is equal to N into E. Here Q is the charge, N is the number of electrons, and E is the charge of electron. So we all know that one electron is equal to 1.6 into 10 to the power of minus 19 coulomb. Charge is quantized in the form of number of electrons multiplied by charge of electron, and the SI unit of charge is coulomb and it is denoted by C. Dear students, now previous slide ಅಲ್ಲಿ current and charge ಅನ್ನು define ಮಾಡಿದ್ವಿ. So current I is equal to Q by T and charge Q is equal to N into E. If ನಮ್ಮ ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಚಾರ್ಜ್ ಅಂಡ್ ಟೈಮ್ ಗಿವನ್ ಇದ್ರೆ ನಾವು ಕರೆಂಟ್ ಅನ್ನ ಈ ಫಾರ್ಮುಲಾದಿಂದ ಈಸಿಯಾಗಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಅದೇ ನಮಗೆ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ಮೆನ್ಷನ್ ಮಾಡಿ ಚಾರ್ಜ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಂದ್ರೆ ಫ್ರಮ್ ದಿಸ್ ಫಾರ್ಮುಲಾ ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್. Here E is known quantity, that is charge of electron, that is 1.6 into 10 to the power of minus 19 coulomb. ಇಫ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾರೆ, ನಮಗೆ ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟಿ ಲೆವೆಲ್ ಜಾಸ್ತಿ ಮಾಡ್ತಾರೆ. ಸೊ ಅವಾಗ ಏನ್ ಮಾಡ್ತಾರೆ, ಕರೆಂಟ್ ಅಂಡ್ ಟೈಮ್ ಅನ್ನ ಗಿವನ್ ಇರ್ತದ. ಏನು ಕರೆಂಟ್ ಅಂಡ್ ಟೈಮ್ ಗಿವನ್ ಇದ್ದಾಗ ನಮಗೆ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟು ಇದಾವೆ ಒಂದು ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಅಂತೇಳಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ ಹೇಳ್ತಾರೆ. ಅವಾಗ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಇವೆರಡು ಫಾರ್ಮುಲಾನ ಅರೇಂಜ್ಮೆಂಟ್ ಮಾಡ್ಕೋಬೇಕು. That is I is equal to Q by T and Q is written as N into E divided by T. So ನಮಗೆ ಏನು ಬೇಕು, number of electrons. So N is equal to I into T divided by E. This is the number of electrons find ಮಾಡೋಕಂತ ಫಾರ್ಮುಲಾ. ಸೊ ಈ ತರ ಕ್ವಶನ್ಸ್ ಅನ್ನು ಅರೇಂಜ್ ಮಾಡ್ತಾರೆ. Next is voltage or potential difference. So voltage is defined as work done per unit charge. Here V is the voltage, W is the work done and Q is the charge. So one battery voltage ಅನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಕ್ಕೆ ಎಷ್ಟು ವರ್ಕ್ ಮಾಡತೈತಿ ಪರ್ ಯೂನಿಟ್ ಚಾರ್ಜ್, ದಟ್ ಈಸ್ ದಿ ವೋಲ್ಟೇಜ್. ಅಂಡ್ ದಿ SI unit of V, that is voltage is volt, that is denoted as V, and SI unit of W means that is work done is joule, that is denoted as J. Next is resistance. Resistance means the opposition to the flow of current in an electric circuit. On circuit ಅಲ್ಲಿ electric current ಗೆ opposition ಏನಾಗಿರ್ತದಲ್ಲ, that is known as the resistance. Here resistance is denoted as R. It R is directly proportional to the rho and directly proportional to the L and inversely proportional to the A. Means here R is equal to rho L divided by A. Here rho is the resistivity, means ಯಾವ type of material ಅದ that indicates the resistivity, and L is the length of that material and A is the area of that material. So here SI unit of length is meter and SI unit of A means the area is meter square, and SI unit of rho means that is the resistivity, that is ohm meter, or now symbolically ಬರೆಯುವುದಾದ್ರೆ omega meter, that is m ಅಂತ ಬರಿಬಹುದು. Next SI unit of resistance is ohm, that is denoted as omega. Next is Ohm's law. Ohm's law is defined as the electric current through the conductor is directly proportional to the voltage and inversely proportional to the resistance. Here V is directly proportional to I, means the voltage is directly proportional to the current, and V is equal to I into R. So here R is the resistance. So V is the voltage, I is the current, and R is the resistance. The SI unit of voltage is volt, that is denoted as V, and the SI unit of I is ampere, that is current of the SI unit ampere and denoted as capital A, and the SI unit of R, it is resistance, is equal to ohm, or we can symbolically denote it as omega. Next is series formula. In case of resistance, when they are connected end to end, then we can find the equivalent resistance as Rs is equal to R1 plus R2 plus R3, and here the current remains same, means when the current pass through this end A end to B end, the current remains same and voltage divides. This is the series combination for the resistance. Next is parallel combination. For the resistance, when they are connected parallel to each other, then we can find the equivalent resistance by using this formula, that is 1 divided by Rp is equal to 1 by R1 plus 1 by R2. So here current divides. When the current flow from A end to B end, the current divides and the voltage remains same. Next is energy and power formula. Here E is equal to VIT and P is equal to VI. These are the general formulas for the energy and power. E is equal to I square RT and P is equal to I square R. These are the formulas used for series combination. And E is equal to V square by R into T and P is equal to V square by R. These formulas are used for parallel combination problems, and we can relate energy and power as P is equal to W by T and P is equal to E by T. Here the SI unit of energy is joule, and we can write symbolically as J, and the SI unit of power is watt, and we can denote it as W. Next is light formulas. For reflection, we can find the radius of curvature. This radius of curvature is equal to R is equal to 2 into F, or we can write F is equal to R by 2. Here R is the radius of the curvature and F is the focal length. The distance between the center of curvature to this pole is the radius of curvature, and half of this is known as the focal length, that is denoted as F. Next is mirror formula. For reflection, mirror formula can be written as 1 divided by focal length is equal to 1 divided by image distance plus 1 divided by the object distance. Here F is the focal length, V is the image distance, and U is the object distance. Next is magnification. Magnification is the ratio of the height of the image to the height of the object, and it is defined as magnification is equal to, that is the image distance divided by object distance. So m is equal to hi divided by h naught, or m is equal to minus v divided by u. Here hi is the height of the image and h naught is the height of the object. Here v is the image distance, object distance is u, and here all lengths are in centimeter, and m means the magnification is unitless because this is in the form of ratio. Next is light formula for refraction. First one is Snell's law. Snell's law states that when light passes from one medium to the another medium, it bends at the boundary. So this is the medium 1 and this is the medium 2. When light travels from this medium to this medium, the light bends at this boundary. This is known as the boundary, and this is the normal. And this I is the angle of incidence and this R is the angle of refraction. Na is the refractive index of medium A and Nb is the refractive index of medium B. So we can write this Snell's law as sin I divided by sin R is equal to NBA, means the refractive index of medium B with respect to refractive index of medium A is equal to NB divided by NA. Here NB is the refractive index of medium B divided by NA is the refractive index of medium A, is equal to VA divided by VB, that is the velocity of light in medium A divided by velocity of light in medium B, that is equal to lambda A divided by lambda B. Here lambda A is the wavelength of medium A, means light of wavelength A, and lambda B is the wavelength of light of medium B. So here velocity and the lambda wavelength are directly proportional to each other, and the refractive index and velocity are inversely proportional to each other. Next is refractive index, and it is denoted as n. This is the unitless quantity because refractive index can be defined as the ratio of the two velocities or the ratio of the two wavelengths. There are two types of refractive index. First one is absolute refractive index and second one is relative refractive index. So here, when a ray of light passing from air medium to the another any x medium, that is known as absolute refractive index. Here we can find the refractive index of this x medium is equal to c divided by vx. Here c is the speed of light, and that is 3 into 10 to the power of minus 8 meter per second, means the SI unit of velocity is meter per second, and vx is the velocity of light in the x medium. Next is relative refractive index. When a light passing from any medium to the any medium, means when a ray of light passing from this a medium to the b medium, that is known as the refractive index, relative refractive index. So a refractive index of medium b with respect to medium a is written as va divided by vb, means the ratio of the velocity of light in medium a to the velocity of the light in medium b. Next is lens formula. In refraction, we can write the lens formula as 1 divided by focal length is equal to 1 divided by image distance minus 1 divided by object distance. Next is magnification. Magnification by definition we can write as the ratio of the height of the image divided by height of the object. And here magnification can be written as m is equal to v divided by u. Next is power of lens. So power can be defined as power is equal to 1 divided by focal length. If the focal length is given in meter, then use this formula. If the focal length is given in centimeter, then use this formula. The SI unit of power is diopter, and this power is inversely proportional to the focal length. If focal length increases, the power decreases, and the focal length decreases, the power increases. We can find the nature and size by using the magnification in light. If the magnification lies between 0 to 1, means the image is diminished, means compared to the object height, the image height is smaller. So when the magnification lies between 0 to 1, the image is diminished. Next, m is equal to 1 means magnification is equal to 1 means the image height and the object heights are similar, means they have the same height. Next, m is greater than 1 means enlarged or magnified image we will get, means here compared to the object height, the image height is greater. Next, m is equal to plus means m, the magnification values is in positive, then the nature of the image is virtual and erect. If the magnification value is in negative, then the nature of the image is real and inverted. We have just revised all important formulas of light and electricity. Now, keep practicing from your formula notebook, revise daily, practice numericals, believe in yourself. All the best for your exams. See you in next video. Thank you. Like, share and subscribe our channel.